Welcome to the video on nucleophilic acyl substitution. With carboxylic acids and their derivatives, we have a situation where we have a carbonyl that is bonded to an atom or a group that can leave. An atom or a group that is a weak base, weak conjugate base, weak enough that it'll be fine on its own. And so for carboxylic acid and carboxylic acid derivatives, meaning carboxylic acids, acid chlorides, acid anhydrides, esters, and amides. Those compounds have a leaving group and will undergo what is called acyl substitution. And what I mean by acyl substitution is that if we have that compound with the leaving group and a nucleophile attacks, the nucleophile is going to attack the carbonyl, kick up, and then in a second step, I'm showing it in a different color. On the next slide, we'll see that it's two distinct steps. We kick down and kick out. And then what we get is replacement of the leaving group with the nucleophile. So the nucleophile is now attached and the leaving group is gone. Let's just for a second step back and talk about ketones and aldehydes. If we talk about ketones and aldehydes where we have two R groups or an R group and an H, R or carbons and H's cannot leave. And so these compounds right here do not undergo nucleophilic acyl substitution. It turns out, and we'll learn in organic too, that instead these compounds undergo what's called nucleophilic acyl addition. And we'll learn about that in organic too. And so now really quickly, the mechanism of acyl substitution. We have a nucleophile that does nucleophilic attack on the carbonyl carbon, and then it kicks those electrons up onto the oxygen. And so this one right here, we're going to call our tetrahedral alkoxide intermediate. And so what happens with that intermediate, and so in a second step, we have the lone pair electrons kicking down and then kicking out the leaving group. So as this lone pair kicks down, we reform the double bond and then we kick out the leaving group. And so our final product is still sp2 hybridized, just like our starting material, and it has the nucleophile attached now instead of the leaving group. And then the leaving group is on its own. So this is a two-step mechanism where we have nucleophilic attack with a tetrahedral intermediate, and then we have loss of a leaving group, and that is going to form our final product. So remember, H and C cannot be expelled, cannot leave. And so ketones and aldehydes do not undergo this reaction. Okay, great. I hope this helps give you insight, and we'll jump into this a little bit more in next class. Good luck.